This video is a continuation of going through the various hypothesis tests involved in a 2x2 between subjects factorial ANOVA. So I ended the last video talking about writing up this second main effect. And so far we have the main effect comparing people with jobs to those without jobs was not significant. And then we need to add in the statistics that we use to reach that decision. And so let's look to the SPSS output to find the information we need. So again, we'll start with F here because the F statistic is what's used, or the F ratio is what's used to test our hypotheses in ANOVA. In parentheses, we're always going to have our 2 degrees of freedom that were used. And so here we're going to use the degrees of freedom. The first one will be the one in the same row as the variable for the main effect you're testing. This one we're testing the main effect of job. So all of our information's going to be coming from that row primarily. So the first degrees of freedom is the one that's listed in that row. The second degrees of freedom is always going to be this error degrees of freedom. So the way we'll indicate both of those is we'll put 1, comma, space, and then the error degrees of freedom of 192. And so our F ratio is here, again, it's on that same row as our variable that we're testing here, which was the main effect of job. So that is our F statistic that we're going to report. Again, I have rounded to 2 numbers after the decimal place based on APA style requirements. And anytime we failed to reject the null hypothesis or did not find a significant difference, we don't actually report the p-value. Instead, we just end the sentence by saying NS. Don't forget that we don't report our measure of effect size if we did have a non-significant finding. Essentially, once we decided that our difference was not significant, what you're saying ultimately at that point is there is no effect. So it wouldn't make any sense to report your effect size because you already concluded that there is no effect or there is no difference. So we will just end that sentence by reporting our F statistic and then NS. So now let's talk a little bit more about interactions before we do that hypothesis test. So I already mentioned this a couple of times when we were looking at the data before, but as a reminder, a cell, so whenever you hear the term cell, that's going to be the boxes inside of your table that reflect the combination of your different levels for each of your factors. So I'm going to show you what the cells are in the table in a second. Essentially what the interaction is looking at is it does an ANOVA test, so another ANOVA hypothesis test is done to examine the interaction, which essentially just looks for differences between the cells in our study. So it looks for unique combinations of your 2 factors. And if there's a specific combination of your 2 factors that is leading to a significant difference between those different cells. So we'll look at more detail in a second of how, or of what means are being examined in the interaction effect. But in this third hypothesis test, again, what we're examining overall is we're looking at the interaction between our 2 factors. So in this example, we were looking at the 2 factors of being a student or not and having a job or not. And we were looking at how they were related to caffeine consumption. So the interaction looks at the combined effect of both of those factors. And when we're stating our hypotheses for the interactions, you'll notice that these look a little bit different than the previous hypotheses. Basically, we're just going to be stating these hypotheses in words, whereby the null hypothesis is that there is no significant interaction between these 2 variables. So being a student and having a job, there's no interaction between the 2 in determining caffeine consumption in the population, versus our alternative hypothesis, which states that there is an interaction between these two variables in the population. So our hypotheses are always stated about the population level, so make sure to include that in your hypotheses. So let's look back at our data, and specifically this table that we constructed that represented all of the means that we are interested in. So the last two hypothesis tests use only the marginal means, which were the means that we had calculated out here in the margins, representing the overall mean for students and non-students, and then people with jobs, people without jobs. We only were comparing all those marginal means up to this point. So the interaction is going to look at comparing each of these cell means to each other and really looking to identify if there's a specific combination of being a student or not and having a job or not in determining that you are going to drink a lot more caffeine or a lot less caffeine. So it's really looking to see, is there a specific combination of these two factors that really affects caffeine consumption? So these are the different means that we'll be comparing in our interaction. Let's talk about how to interpret the SPSS output first before we compare any of these cell means to each other. So in looking at our SPSS output, the interaction effect is going to be represented here. So in this case, my two factors were being a student and having a job. If you're working with different output, these might have two different variable names, but the interaction effect is always going to have that asterisk in between your two factors. So it will be the whatever times whatever. So in this case, is the interaction between being a student and having a job. So this is the row that we're going to look at for our hypothesis tests regarding the interaction between being a student and having a job. So again, just like before, we're going to look to that SIG column to interpret the analysis. So the same rules apply here as they do really in every analysis. We're going to compare that SIG column, which is our p-value, to our alpha level. So our default alpha level is 0.05, so if we weren't given an alpha level, we could just go ahead and assume that our alpha level that we're going to use is 0.05. So comparing that SIG column of 0.030, comparing that to an alpha of 0.05, we do see that that value is smaller than 0.05. So our p-value is less than the alpha level of 0.05, and so in this case we are going to make that decision to reject the null hypothesis, since that SIG value is less than 0.05. So anytime we're rejecting our null hypothesis, that means there is a significant difference, or in this case, there is a significant effect. So our decision here for our third hypothesis test is to reject the null hypothesis. In other words, there is a significant interaction. So let's talk a little bit more about what that means when we have a significant interaction. So when you do have, first off, when you do have a significant interaction, that interaction basically makes the main effects, if you had any significant main effects, it essentially makes them uninterpretable. So the interaction effect, if you have a significant interaction effect, that's always going to be considered more important than the main effect. Because essentially the interaction effect is saying that that main effect is conditional. It's dependent on the other variable that was being ignored. So the way that we indicate the interaction as being more important than the main effect is in our conclusions, we'll use this word qualified. And we'll say that the main effect was qualified by the interaction. So you'll see that in a second when I return to my conclusion. But that's the reason why we'll use that word qualified is it says that basically that main effect is now dependent on this interaction effect. And also another thing to note about interactions is the easiest way to actually understand an interaction and your data is usually to use a figure or a graph. This is also the ideal way to present your findings from an interaction. Almost always, if you have a significant interaction, you should probably put your means into a graph of some sort. So it could either be a bar graph or it could be a line graph. But either way, you almost always want to present your interaction findings in a figure. And in general, when we're trying to explain our interaction, one way that I think is easier to try to explain your interaction effect is to at least explain what combination of your two factors led to the highest and lowest values. So we'll look at that in a second in terms of how we can identify what combination resulted in the highest and lowest values. So let's start out though by adding to our conclusion. So again, we're still adding to the same conclusion. All of this is in the same paragraph that we were working with before. So we're just going to go ahead and add this part to the end of, that last hypothesis test we just did, hypothesis test 2. The end of that, we're going to add this next sentence. So, however, the main effect of student was qualified by a significant interaction between student and job. So again, we're using that word qualified to indicate that this interaction effect, since it was significant, it is more important than the main effect. So after that, we want to say our statistics that we use to reach that decision. So again, we use the F statistic, and much like in the other two examples, we're going to use the first degrees of freedom will be on that same row as the analysis. Our second degrees of freedom, again, is going to be that error term. So here we'll have 1, space 192. And our F statistic is going to be, again, in that same row. So the same row as the student times job. So we're going to make sure to round that value appropriately. That is our F statistic. And then here we have our p-value, which is labeled SIG on SPSS for some reason. And we will actually just report the actual value for this p. So ideally with APA style, if you can report the actual value for p, you go ahead and report it. So we're going to say p is equal to 0.03. Since we rejected the null hypothesis and did find a significant effect, we would report our partial eta squared here, our measure of effect size. So I'm going to add that to the end of the sentence. So that is where you get all the statistics from, and we will plug all of that information in here at the end of that sentence. So there's all our stats. And so next what I want you to do is to look to your SPSS output for the plot. You actually have to request the plots to be presented in your output in SPSS. So if you don't have a graph in your output, that's because you didn't ask the program to give it to you. So it doesn't really matter which variable is on the y or horizontal axis and which one is different points. So we could have just as well had the job on this x-axis and then different lines for student. Doesn't matter which way you do it, just as long as you look at one of the graphs. One of the major things you want to look for when looking at these graphs is really the highest and lowest scores. So you'll see that the highest score here is identified, it's way up here, and it's a green line. So the green line corresponds to the people that said, no, I don't have a job. And then you can see that that data point is above the no, I am not a student. So this data point represents the people who don't have a job and also aren't students. So that's the highest value. And then we see our lowest value is here, which is the people that are a student and don't have a job because it's green.